The story is a fixture of history. An apple drops from a branch, hits the ground, and a theory of the universe is born. We have accepted a clean, sequential narrative. The apple falls, Isaac Newton sees it, and the concept of universal gravitation instantly exists. This sequence omits the actual cognitive machinery required for human discovery. New ideas do not spontaneously generate from nothing. An insight is the final, observable stabilization of a massive, pre-existing neural network. To understand how Newton arrived at his conclusion, we must map his mind through the framework of tokenization and subthreshold dynamics. The subjective sense of a thought appearing in an instant obscures the objective, slow electrochemical reality of a network reorganizing itself. Stripping away the myth of spontaneous genius forces us to view human cognition strictly as a complex, interconnected computational assembly. Long before the famous event, Newton spent years in isolated, rigorous study at Woolsthorpe Manor. This chart shows the planetary orbits and geometric solids modeled by Johannes Kepler, representing the specific astronomical data Newton was absorbing. The classical handwritten mathematical manuscripts he studied, like this one, demonstrate his simultaneous immersion in mathematical proofs and terrestrial geometry. Years of ingesting this information built discrete cognitive assemblies in his brain. We can model these concepts as individual tokens: motion, astronomy, falling, mathematics, force, and the moon. Repeated study of how these concepts interact forged topological connections, physical, electrochemical pathways linking these distinct ideas. These tokens operated in a baseline state called subthreshold excitation. They hover around 60 or 70% activation, constantly fluctuating below the threshold required for conscious thought. Because these signals remain below the line of awareness, they do not register in the mind as active ideas. Newton's brain was a highly volatile, densely wired computational landscape, perfectly primed and waiting for a final input. The falling apple was strictly a sensory trigger, an ordinary event. The apple does not create the concept of gravity. It acts as a perturbation, a final injection of energy into the active system. That visual input causes an immediate spike in the specific neural token associated with downward motion. Excitation energy bleeds outward from that single point, propagating along the pre-existing topological lines Newton had spent years carving. As the energy travels, adjacent concepts like terrestrial motion and force rapidly spin up. The system is implicitly executing a computational query. What else behaves exactly like this? Without conscious permission, the excitation bridge jumps across from terrestrial math into celestial bodies, driving the moon and planetary orbit tokens into high excitation. Multiple previously isolated cognitive assemblies are now co-excited simultaneously. The path of this insight is entirely dictated by the hidden architecture of the mind the apple falls into. This presents a paradox. If this process relies on years of structural topology and complex subthreshold propagation, why does it feel like a sudden discovery? This chart tracks excitation against time. To understand the experience, imagine slowly filling a bucket with water. The connections and partial excitations have been quietly accumulating over months of study, creeping upward toward the brim. In the moments before the event, the network is silently accumulating the final percentages: 96, 98, 99%. The apple provides the final perturbation, pushing the system over the 100% threshold. Human consciousness is blind to the long, slow curve of the filling bucket. It only possesses the sensory equipment to detect the overflow. In doing so, we mistake the speed of the final realization for the speed of the entire cognitive process. This arrival in awareness is the ringing of a threshold alarm. It serves as the notification that a long-running computation is finally complete. We can see the ultimate effect of this computation by looking at the final post-perturbation state of the neural network. Before the final trigger, the architecture was fragmented. The falling apple, the motion of the moon, and the orbits of the planets existed in 3 distinct, separated clusters. Holding 3 isolated mental models requires high cognitive energy and multiple competing sets of assumptions. The brain naturally seeks efficiency through token compression. a drive to discover a highly coherent, energy-efficient state. Driven by the sudden co-excitation, these distinct clusters collapse inwards to form a single explanation: gravity. This single token remains permanently stable because it successfully predicts physical observations across the universe while requiring far fewer structural assumptions. The title page of Principia Mathematica, shown here, represents the physical output of Newton's reorganized cognitive state. Universal gravitation was the inevitable, elegant compression of a meticulously built neural machine.